Good morning everyone. So in the previous video we had seen property 2. Now we'll see property 3. Okay, so it says if two rows or columns of a determinant are identical, the values of the determinant is 0. So here you see the first row and the second row same, identical, therefore your determinant will be equal to 0. Let us see by example. If I write this 1 2 3 1 0 1 1 2 3, so here can you see first row and the third row, they are same, means identical. So let me expand along the first row. Okay, so see what will happen. So here we get -2, here we'll get -4, and here we'll get +6. So -6 plus 6 is equal to 0, is equal to 0. So this was your example 1. So here you saw that first row and third row, they were same, identical, so you saw determinant came 0. So from onwards, okay, if you see any determinant where two rows or two columns or more than if two or more than two, okay, rows or columns are equal, okay, identical or same, you can say, then determinant will be 0. So next here 1 2 1 0 1 0, and then 1 2 1. Okay, so here if you see column 1 and column 3, they are equal. So let us try to find the determinant. I'm doing along the second column, so you should remember this sign pattern. So sign pattern is this. Okay, so with the first element you have to take minus, but here first element is 0, so no need to take. Second is 1, so we can take plus, and third one is 0, so no need to take. So we have to find for only this. Okay, so +1, so simply 1, then forget this row, forget this column, so remaining 1 1 1 1. Okay, so you get 1 minus 1 equal to 0. So it's clear now. Okay, if two rows or columns of a determinant are identical, then the value, okay, then value of the determinant is 0. Okay, so your job is to write down this property. Okay, if you want to write the example, you may write, otherwise not needed. Now let us discuss property 4. Here it says if all the elements of one row, if all the elements of one row or column are multiplied by the same constant, then the original determinant is multiplied by that constant. Okay, so here if you see the first row, okay, is multiplied by a constant, each element, okay, is multiplied by the same constant, then determinant will be k times, okay, this, k times this. Now I will discuss this later on. First let us try to understand this first statement. Okay, so example, here let's say I have this 1 2 3 0 1 minus 1 0 1 1. So this will be equal to 2. Yes, because we have already solved this. Now see this. If I write one determinant over here, which is like this. Okay. Now we have to find determinant of this. So here what you observe is, in the first row, okay, each term is multiple of 3. Each term is multiple of 3. So I can take out 3 outside. So I'll get 3 over here, and then I can write 1, 2, 3, 0, 1, minus 1, 0, 1, 1. Yes. But this is nothing but this delta. Yes. So your answer will be 3 times delta. But what is the value for this? It's 2. So 3 into 2, you get 6. Okay. Now let's say I take one more determinant, okay, and it is like this. 1, 2, minus minus 6, 0, 1, 2, 0, 1, minus 2. Okay. Now here you observe that the determinant that I wrote just now, okay, column 3, okay, each term, each element in column 3, okay, is multiple of 2. Yes, yes or no? So what I can do is I can take out 2 outside, then I get this. Done. Now further what you can do, minus can be taken out as common from column 3. So I'll get minus 2, 1, 0, 0, 2, 1, 1, 3, minus 1, 1. Now this is exactly delta. So your answer will be minus 2 times delta. So minus 2 into delta value is 2. So you get minus 4. Yes. So this statement is trying to explain what I did in examples. Okay. That if all elements of one row or a column are multiplied by the same constant, then the original determinant is multiplied by the constant. So here what did I do in these examples? This was the original one. Yes. And in this original, what I did, to the first row I multiplied each element by a constant. That constant was 3. So in that case, what resulting determinant, okay, will be 3 times the original value. Okay, that's why 6. And in this, what did I do? I obtained this by multiplying each element of column 3 by minus 2. So answer for this would be minus 2 into value for the original determinant from where you obtained this. Okay, so that's why answer minus 4. Done. Now see this one. Note. Okay, here first row is multiplied by a constant m, second row is multiplied by a constant that is n, then the third one is multiplied by a constant that is k. So in that case, okay, answer would be m into n into k into the original determinant value. Okay, like here, let's say our original determinant is this 1 2 3 0 1 minus 1 0 1 1. This is the original one. Okay, now what I do, I obtain one determinant by multiplying the first row by 2. Okay, so 2 4 6, and second row by 3, so 0 3 minus 3, and the third row by minus 2, so 0 minus 2 minus 2. Okay, so answer for this will be what? Since first row, okay, of this original has been multiplied by 2, okay, and this is by 3 and this by minus 2, so answer will be 2 into 3 into minus 2, okay, into the original, okay, means into the value for this one. Okay, so you will get this. So here 2 2s are sorry, 2 3s are 6, 6 into 4, so you get minus 24. Okay, because 2 was common in this, so 2 came out. 3 was common in this, so 3 came out. Minus 2 was common, so minus 2 came out. So at the end you were left with this 1 2 3 0 1 minus 1 0 1 1, but you know value for this is 2, so you got 2 into 3 into minus 2 into 2, so it's coming minus 24. Yes, so this was all about the fourth property. Okay.